You are studying a population with sum of squares equals to 100 and variance equals to 4. Determine the value of the sum of, in brackets, x minus the mean for the population. Okay, now this one is a trick question. They look like they're trying to make you think that this information here and here is important, when in fact this value that we're looking for here, this is the sum of not the squared deviations. This is not the sum of squares, which we know is 100. It's the sum of just the deviations. And sum of deviations is always equals to 0. So let's have a look at why that is. So my answer is going to be 0, but I want to show you that this is not important and this is not important. Now let's take just take a simple set of numbers like 1, 2, and 3. Now this will work for any set of numbers. Just picking a small set of numbers here, just to get through this with the math not being too complicated. You might get you might pick some numbers where you get some decimal places and so on, but this will just keep the example nice and easy. Now, if I want to find my deviations and then sum them up by adding this column, I need to start by, first of all, finding the mean, because I'm going to be subtracting the mean from each one of my x values. So the mean is equals to the sum of x over n. So if I add these three up here, that will give me the sum of x. So 1 plus 2 is 3, plus another 3 is 6. So I've got 6. There's 3 values there. So this gives me an average of 2. So in order to fill out this column of deviations, what I have to do is I have to take each value of x, so x minus the mean. So it will be each x minus 2. So 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. You can see that when you add these up, the negative 1 and the positive 1 will cancel. The 0 doesn't contribute anything, and so the answer will be 0. Okay, so I've got the sum of my deviations, like they've talked about here. It's going to be 0. But now what if I were to, let's say, change one of these numbers? Let's make this a 2. Now that's going to complicate things a little bit here, because this won't add up to 6. Instead, now this is going to add up to 2 plus 2 plus 3. That'll be 7. And it's going to change everything. The average is going to be a little bit different. So I'll get rid of all this stuff here. But will it still give me a sum of 0? It seems like it shouldn't, because I had it working out to be 0 when it was 1 plus 2 plus 3, but now it's 2 plus 2 plus 3. But I'm going to work this out, and I'm going to show you that it does in fact come out to be 0. So let's go through the math here. So it's going to be 7 over 3. All right, so now 7 over 3, that is 2.333, and so on. This carries on. If I take that away from each one of these, so 2 minus if I take that away from each one of these, so that's 2 minus 2.333, that's going to be negative 0.3333, and so on. So will this. And this one, 3 minus 2.3333, repeating, is positive 0.6667. When you add these ones up, you'll end up getting 0.0001. Now that's not equals to 0, but you can see that I was rounding off. I stopped at 0.3333, but this keeps going. Here this would be 0.66666666 and so on, but I had to stop going. I had to stop at some point, so I rounded off to 4 decimal places. This is just a little bit of a rounding error. No matter what set of numbers you have here, and no matter how many numbers you have here, once you find your deviations and you sum them up, you're going to get either 0, or maybe because of some rounding error, you're going to have very, very, very close to 0. So the sum of deviations is always equals to 0, except like in my example here where there's a little bit of rounding error. That certainly isn't one of the choices here, so we can safely say that the answer is 0. It has nothing to do with the other information.